Today we're going to do lesson 5.4. It's our last section that we're going to cover before we take our quiz on Friday. All right, for those of you that still are struggling with a couple of the methods that you've learned, and we're going to go over those here in just a second, this will be a good day for you to review those methods, for you to ask some questions. All right, so in this lesson we are going to solve special systems of linear equations. So let's just review a few things before we start on today's lesson. First of all, we've learned 3 ways to solve a system of equations. Who can raise their hand and tell me at least one way that we've learned? Amelia? Elimination. All right. Avery?
Submission.
Okay. Close. Loza? Graphing. All right. And the third way, Jaden? Substitution. All right. Substitution. So we've learned how to solve by graphing, substitution, and elimination. Now, the first question we're going to ask ourselves is this one right here. It says, when using the graphing method, all right, let's go all the way back to the graphing method. To solve a linear equation, how do I know my solution? So basically what I'm asking you is, what is the solution to a system of equations? And we spent a long time yesterday going back and looking this up. Okay, so again, by raise of hand, does anyone know when I am solving a system of linear equations, what is my solution? What am I looking for? Jaden? The point of intersection. Very good. So no matter the method, I'm looking for the point where my 2 lines would intersect. So the next question is, what if the lines never cross? If the solution to a system is the point of intersection, what happens if the lines never cross? Well, what kind of lines have we learned about that never actually cross each other? Parallel lines. Very good. So if our lines are parallel and they never cross, what's our answer?
No solution.
No solution. Very good. Now, look at your last question on here. What if the lines turn out to be the exact same line? So let's say I give you 2 equations. One of them is written in standard form. One of them is written in slope-intercept form. And when you graph them, you find out you have the same line twice. So essentially, you're laying one line on top of the other. What's the solution?
All real numbers.
It can't be one, because one solution is when 2 lines intersect at one point. If a line is laying on top of a line, how many points of intersections are there? Infinitely many, right? Those 2 lines are intersecting all along itself. So infinitely many. If I end up with the same line twice, then my solution is infinitely many solutions. So that's what you wrote down first in your notes. The essential question, can a system of linear equations have no solution or infinitely many solutions? And we can already answer that with a yes. Okay? Intersecting lines have one solution because they cross at one point. Parallel lines have no solution because they never cross. And same lines have infinitely many solutions because they cross everywhere. All right? So these are our 3 different types. One solution, no solution, or infinitely many. Now, first thing I want you to notice about example 1. It says solve the system of linear equations. Is there anywhere in the directions where I tell you what method to use? No. So you get to decide what method you want to use. However, I'm going to guide you. I'm going to help you figure out which method would work the best, which method would work the fastest. Okay? We are not going to graph in class today. We're not going to get our phones and use Desmos. But on your homework tonight, if you get to choose your method and you want to use Desmos, great. Keep in mind, though, you have to take whatever Desmos does and you have to write it down on a piece of graph paper. Okay? So if you do choose graphing, you have to make sure you can create the graph on a sheet of graph paper for me. All right, but let's look at letter A. We have x plus y equals 3, 2x plus 2y equals 6. So somebody raise your hand, tell me what method you would use between elimination and substitution, and tell me why you would use it. All right, Amelia? Elimination. You'd use elimination. Why?
Because the problems are lined up.
All right, the x terms, the y terms, and the constants are all lined up. And you remember step number 1 from yesterday? We said for elimination, we have to make sure all of our x terms, all of our y terms, all of our constants are lined up. So I'm with Amelia. If I'm looking at this problem, I'm definitely doing elimination. All right? So, Kayla, you've got a choice to make. Would you like to eliminate x or would you like to eliminate y?
X.
All right, is there a right or wrong answer to that question? No. All right, but she has chosen X. So if we look closely at our X terms, Kayla, what are my two coefficients? Very good. There's an understood 1, and we have a 2. Which means if we're going to do elimination, we need a common multiple of what two numbers? 1 and 2. Now remember, we love when one of our coefficients is 1 because finding the common multiple is simple. Kayla, what is the common multiple of 1 and 2? 2 is the common multiple. Now Blake, if 2 is my common multiple, then which equation am I going to have to multiply, and by what am I going to multiply?
First equation.
All right, I got to multiply the first equation because it has the coefficient of 1. And what am I going to multiply the first equation by? 2, because 1 times 2 is 2. Now Blake, can I multiply by a positive 2?
No, ma'am.
Why?
Because you're not. I don't know.
Okay, somebody help him. Why can I not multiply by a positive 2? Travis.
Because then you're not going to have a positive and a negative to cancel out.
Good. They're not going to cancel out if they're not opposites of each other. And right now their signs are the same. So that 2 that I'm going to multiply by has to be a negative 2. All right? So let's bring down the equation we are not changing. So we're not changing 2x plus 2y equals 6. So let's go ahead and bring it down. Now let's multiply, remember, the entire equation by negative 2. So Carson, negative 2 times x is what? And negative 2 times y is? And equals, what's 3 times negative 2? Negative 6. Awesome. So, Carson, you're on a roll. What's 2x minus 2x? Okay. Now, I'm actually glad she said that, okay, because this is actually a very common mistake. 2x minus 2x. If I write down x as my answer, what is the coefficient of this x?
1.
It's a 1. So is it even possible that 2 minus 2 gives me 1? No. Okay, so when my terms are opposites, it equals what? 0. All right, so we're going to completely cross it out, and we're done with the x's. The x is gone. It's 0x. And what's 0 times? Excuse me. What's 0 times anything? 0. So it's gone. Now, 2y minus 2y. That one cancels out too. And normally, I don't bring zeros down, but is there anything left on the left side of this problem? No, so I have to bring down my 0. Equals, what's 6 minus 6?
0.
So that cancels out, which means, again, I have to bring down a 0. Now, here's the question. Is this a one-solution problem?
Yes.
No. One-solution problems have what as their final answers? Ordered pairs. Do we have any variables left in this problem? No, they all canceled out. So now the question becomes, is the statement left a true statement or a false statement?
False.
True.
Does 0 equal 0?
Yes.
Yeah. So is it no solution or is it infinitely many solutions? Infinite. We've learned in the past that if the statement left is true, it is infinitely many solutions. Okay? And I'm not looking for IMS. I'm looking for infinitely many solutions. Okay? It's my final answer. Now, any questions so far? All right, let's look at letter B. Again, we get to pick the method. So if I'm looking at letter B, Jamara, what would you pick? Which method would you pick based on how the problem is set up? Substitution makes sense here. Why does substitution make sense? Okay. If you remember the lesson, the flipped classroom lesson 5.2, remember the very first step? After we labeled our equations A and B, we were supposed to pick an equation and solve for either A or B. Well, haven't they already done that for us in letter B? They already have y by itself, so absolutely I would pick substitution. Is it my favorite? No. But if I'm going to do elimination, then I've got to move that negative x over to the other side, and that just creates more work. All right? So for letter B, substitution would be most definitely the better choice. Now, let's go through substitution because you did this in your flipped classroom, so I want to make sure you are understanding what you learned. First thing you're supposed to do is label the equations what and what? A and B. So let's go ahead and do that. Step 2 is to pick one of the equations and solve for one of the variables. Well, they already did that for us. So which equation are we going to use right off the bat? We're going to use A because they've already solved for Y. So go ahead and cross it out. And actually, since we're using A and they've already done the work for us, we now can call it equation C. Where are we going to plug equation C? Into the equation we have not used, which is equation B. All right, so let's bring down the problem that we're going to use, which is 2x plus. Now, what are they asking us to do right here to 2 and y? What operation? It's a number. Good. It's a number and a variable side by side. That's multiplication. So when we plug things into problems, especially multiplication, we plug them in parentheses. What for this problem does y equal? What's the expression? So that is what I'm plugging in place of y. I'm plugging the entire expression, negative x plus 3, and then I'm bringing down the rest of the problem. Now, we will not panic here because we have an acronym that we have been using since chapter 1. Don't call me after midnight. What does the D stand for? Distributive. Do we have the distributive property? Yes. Absolutely, right here. So that is what we have to do first. So bring down your 2x. When we distribute 2, Talmadge, what's 2 times negative x?
2 times negative x is negative 2x.
Negative 2x, good. And 2 times 3 is?
You start to me?
Mm-hmm.
2 times 3 is 6.
Good. And then we bring down the rest of the problem. Don't call. What's the C stand for in call? Combine. Xander, do we have any like terms we can combine? 2x and?
4.
Now think about that, Xander. One is on the left side of the problem, one is on the right. Remember, combining like terms is like terms on the same side.
And 2 and negative x, negative 2x.
Good, 2x and negative 2x. Now, let's talk about a mistake that is still being made this far into algebra. There is no reason for me to change any signs. Okay, I am combining these as they are. So just do 2x minus 2x. What is 2x minus 2x? 0. Again, they're opposites. So 2x minus 2x is 0, and that leaves me with 6 equals 4. Now, is this going to be a one solution answer? No. Again, my variables are gone. I have no variables left. So, the statement, is it true or is it false?
False.
It is false. So what is my answer then? No solution. So if the variables cancel and I'm left with a false statement, then my final answer is no solution. Awesome. Any questions? All right. Now, letter C. Normally at this point I'd say work with your table, but I want to talk about letter C. Which method makes the most sense when we're looking at letter C?
Elimination.
Awesome. Elimination. And if you are doing your homework tonight and you see this problem or a problem like it, I 100% would say elimination. However, I want to make sure you understand substitution because, again, you watched a flipped classroom and I was not here the day after to help you with the assignment. So I want to make sure you understand substitution. So let's work through letter C as substitution. All right, just one more time. So if you have any questions, you can ask me. All right, first thing we're supposed to do is label the equation A. Let's do red. We're going to do equation A and we're going to do equation B. Now, step 2, I'm supposed to do what? Tristan? Pick one. Which one do you want me to pick? All right, let's pick A. So we're going to pull A over to the side. We're going to do x plus y equals 3. And we're going to cross out A so we don't try to use it again. Now, Tristan, you also need to pick a variable to solve for. So which variable would you like to solve for?
Y.
All right, she wants to solve for y, which means you have to move what, Tristan? Well, you want to solve for y. So move the x. How do I move it to the other side? Good. Now, here's where you're going to make the first mistake. Is that negative 3x on the right side?
No.
No. Why is it not negative 3x?
Because they're not like that.
They are not like terms. Awesome, Layla. So, Layla, what are we going to bring down then on the right side?
Negative x
Negative x
plus 3.
plus 3. Circle, don't box. And what are we supposed to label this equation? This new equation becomes letter C. Now, where do we plug letter C?
B.
Into the equation that we have not used. So for this problem, we have not used equation B yet, so that's where we're going to plug it. Now the arrow is not necessary on a quiz or a test, but in your notes I want you to draw it. I want you to show yourself what you're doing. So we're taking the new equation, we're going to plug it into the equation we haven't used, which is letter B. So let's bring down the problem. We have x plus 2 again. Y is multiplying, so we're going to plug in our expression in parentheses. What's our expression this time? Negative x plus 3, and then we bring down the rest of the problem. Okay, awesome. And cross out B, so we don't try to use it again. Now, what's our first step? Chase. We're going to distribute. So x plus, or x, let's see what we get. When you distribute the 2, Chase, what do you get?
Negative 2x.
Good. 2 times negative x is negative 2x. And then what do you get, Chase?
6.
Plus 6. Awesome. All right. Layla, what's our next step? What are our like terms?
X and negative 2x.
Very good. X and negative 2x. So, Layla, when we combine those, what do we get?
Negative x.
Negative x or negative 1x plus 6 equals 4. All right, Daniel, what's my next step? I've distributed, I've combined. What's my next step?
Get your answer.
Say that again.
Get your answer.
Okay, but don't call me. What's the next step after combining like terms?
Multiply.
No. Who can help him? All right, Travis.
Add or subtract.
Hold on. That's not M in the statement, don't call me. What's the M stand for?
No. Wait, no.
The variable. Is there any variable to move?
No.
No. So, Travis, that brings us to after, which is add or subtract. So what are we going to add or subtract?
6.
6, Travis. We're going to subtract 6 from both sides. So negative 1x equals 4 minus 6 is negative 2. All right, Xander. Don't call me after midnight. What's the M stand for? The second one. Step is to multiply or divide. So which one are we doing, Xander, to finish this part? Divide both sides by? Awesome. So Xander, x equals what? Positive 2. A negative divided by a negative is a positive. Now, circle, don't box, because it's not our final answer. We've got x. We've now got to solve for y. Where are we going to plug that x value? What's the only equation we have not plugged something or used yet? Okay? The only equation left would be C. We're going to take that x value, we're going to plug it into C. Now, would it be wrong to plug it into A or B? Absolutely not. However, why create more work for yourself? Look at letter C. Y's already alone, so all I got to do is plug 2 in and do a little bit of math. If I plug it into one of the original problems, now I got more work because I got to move more stuff. It just gets more complicated. All right, so I'm plugging it into C. So y equals negative, what are we plugging in place of x? 2. Okay, always in parentheses, just in case, plus 3. So y equals negative 2 plus 3, which is? 1. Circle, don't box, because is my final answer a one solution answer?
No. Yes.
Yes, I've got an x and a y. I know you all meant yes. So what is my final answer?
2, 1.
The ordered pair, 2, 1. Now, if we use elimination, would we have gotten the same answer?
Yes.
Absolutely, we would have. All right? But
Wait.
for this problem, I wanted to show you substitution. I want you to work with your table. So I should hear some very soft talking, but I want you to work with your table to set up and solve this word problem. All right? You're writing a system of equations, and then you get to pick. Do you want to use substitution? Do you want to use elimination? But I want you guys to work together. Xander, tell me the first equation that you guys wrote from the 3 cups of dried fruit and the 4 cups of almonds costing you $6.
3 plus 4, 8.
Okay, 3F, because we're using F for fruit, plus those 4 cups of almonds, so they said 4A. When I add the fruit and the almonds together, the small bag cost me $6. All right, how many of you got the first equation? Awesome. Caleb, what's the second equation?
We did 9 over 2F.
9 over 2. I love improper fractions. So 9 over 2F. Keep going.
Plus 6A.
Plus 6A
Equals 9.
equals 9. Now, Nate, did you guys choose substitution or did you choose elimination on this one?
We chose substitution.
You did choose substitution? Okay. Have you made it that far? All right. So which equation did you use and what did you solve for?
The first one. And we solved for
Okay.
F.
Now, let me ask you this. All right. Let's think through this a little bit. This problem has a fraction in it. So do you really want to get into this whole substitution thing where you're having to multiply by a fraction? Or would it not be better because everything's lined up? Would elimination not be a little bit quicker and a little bit better? Okay. Now again, if you guys did substitution, that's totally fine. It's not wrong. But if you're trying to find the best method, then elimination would have been the better method here. Okay. So who chose elimination? All right. That's what I want to work. You guys keep working it. That's fine. Work substitution. But we're going to work elimination on the board. All right. So Layla, what did you guys decide to eliminate? A, perfect. Because again, we don't have to work with fractions. Let's not. All right, so we got 4A and 6A. So Layla, my coefficients are?
4 and 6.
And the common multiple of 4 and 6 is? 12. Is there another one you could have used? 24 would have worked. Okay, but I like 12. So what are we multiplying the first equation by if we're trying to get a common multiple of 12? Okay, 3. And she chose negative. Why did you choose negative 3?
Because the numbers are the same.
Good. My signs are the same. So at least one of the numbers I multiply by has to be a negative. And then for the second equation, what did you guys multiply by?
2.
Positive 2. Awesome. That is how I'm going to get the common multiple of 12. Now, let's work it out. We have negative 3 times 3F, which is negative 9F. Negative 3 times 4A is negative 12A. And negative 3 times 6 is negative 18. All right? What's 2 times 9 halves F? 9F. The 2's cancel. So it's 9F. All right? 2 times 6A? 12A. And 2 times 9? 18. So what happens to negative 9F and 9F?
Cancel.
What happens to negative 12 and 12A and positive 12A?
Cancel.
So I'm left with 0 on the left side. And what happens to negative 18 and positive 18?
Cancel.
Cancel. So I'm left with what on the right side?
0.
0. So my variables are gone. So what's my final answer? Be careful. Infinitely many. My equation is true. The statement left is true. 0 does equal 0. So when it's a true statement, it's infinitely many solutions. So in the context of this problem, look at what they asked us to find. They wanted us to find the price of 1 cup of fruit and 1 cup of almonds. What does it mean if it's infinitely many solutions? It means there's a lot of different combinations that would make true statements. So there's a lot of different costs for a cup of dried fruit and a cup of almonds that would make a true statement. So infinitely many. When I worked this problem out the first time, it threw me off. I was like, wait, this is a word problem. It can't be infinitely many. But it can, and it is. So that is lesson 5.0.